All right. Hi there. Happy Friday. If you missed it, we are getting used to being on time together by making sure your electronic devices go all the way away and getting out your binder and a pencil. So, hey, without looking at your notes, because you either have this paper turned in to me or you have it, can you label these three parts of the nucleotide? Do you remember the words that we use to describe the three parts? This particular one is cytosine, but this could be an A, a C, a T, or a G. Yeah? Here they are. So every nucleotide, which is the building block of DNA, has a phosphate group, a nitrogenous base, and then under here is the sugar. In this case, it's deoxyribose sugar. So today, we're going to analyze our results exploring enzyme shape change. As you remember from last time, we tried to change pH, which will change how a protein's amino acids interact with each other, and therefore the shape of the protein. So we're going to begin by talking about binder setup today. We are doing a binder check today, and it will help make sure that you have all your stuff set up and working. So if you are absent and you see that show up as a 0 and missing, please come to class. And when we do the week 2 binder check or the week 3 one, whatever the next one is, I'll go back and give you full credit for this one if your binder at that time is up to date. So I also gave everybody the Unit 1.1 study guide and vocab. So this class goes pretty quickly. Each unit is a couple days of instruction. So 1.1 includes a lot of the ideas we've already learned about, like the building blocks of proteins, the molecule that stores genetic information, the number of hydrogen bonds that the two bind with, right? Here's a place for you to sketch and label the parts of the nucleotide. You can go back in this video if you need to. There are some stuff we haven't learned yet, like you haven't learned anything about this picture. We'll learn about that next week. But you should expect a little quiz about the topics that we've covered. And then we are going to ask you to do some dynamic vocabulary. So you'll see this updated in your, we're going to ask you to do a study folder, and we'll talk more about that next week. You'll have 3 or 4 1.1, 1.2, 1.3, and 1.4 are in this unit. And you'll have little vocab lists for all of them. So more about that soon next week. For now, though, our big goal is to finish the lab. And just a heads up about late work, you should be 100. We haven't had any quizzes yet. So all your work should be 100. So today I handed out the colorful table of contents. This year, the paper happens to be pink. It just so happens. And so this page is pink. So far, we've written in everything that you have gotten from us in class, including the study guide and vocab. Please note the study guide and vocab is not something you turn in, but you should do it. It is a way to study for this class. So some things in the grade book go in as labs. I'll always mark them by writing lab. And then starting next week, we'll take time during class to write down these pieces. I don't love doing binder checks. It's like not my favorite thing in the whole wide world, but I know when I do binder checks that people do better in the class. So you will be seeing me do some binder checks. You can decorate your binder, but you have to keep it G-rated for all audiences at all time. Our binder setup is required for this class. You can set yours up front to back or back to front. And just a reminder, this bio binder has the last U for Bio 2 as well, so please treat it respectfully. Alrighty, so we learned about DNA. This is not a picture of DNA, but I think it's funny every time. You know now what's wrong with this picture. It's not just one piece all the way across, right? It's 2 things that are held together with hydrogen bonds. You know that this one loops in a weird way. You know that most often, especially in humans, they're on long linear shapes. So and we've learned about catalase, right? Catalase is an enzyme that protects living things from dangerous hydrogen peroxide. Yeast and peas and people and polar bears have this enzyme. And now it's time for graph time. So today, we're going to talk through ideas about graphs and graphing, ask you to make a graph, and answer some follow-up questions about the lab. So here is a bar graph map for students who are younger than you are, transparently. So you'll see that the graph has a title. This is a bar graph, and the labels of the categories tells us what each bar stands for. The orange is showing us the labels for the axes. This is the number of fruits that people have purchased in each category, and this is the type, right? There's also a scale on this part, the numbers to show how many go over here. So with that in mind, we've set you up yet another graph, just like we did for toothpick ace. But this time, because what we changed was the pH, it doesn't fit really well on a number line, like a ruler line. And so we are going to make a bar graph, a bar for control where the average is up there in the middle, one for acidic where the top of the bar is the average time, and one for basic. And you'll see control, acidic, and basic. So what if your average for the control is 30 seconds? You do the math as indicated on the worksheet, you get 30 seconds for the control. You're going to draw a bar that is 2 or 3 across. I like 3 just because of how this graph paper is, and goes up to time in seconds to 30 times in seconds. So what we're doing today while you were gone is that we finished how does enzyme shape affect reaction rate, including collecting more data and finishing the questions on the back. People showed that to me. You'll just turn yours in if you're working late. Late work, resubmits, and binder organization. And if you have 100 in our class, this time people could use their phone until the cool down. So where have we been? We've been studying enzymes this week and thought about using the fact that catalase makes molecular oxygen, which floats, as a really good metric. In the lab, we changed the environment to change enzyme shape and talked about that. But a powerful shape-changing mechanism, and one that actually provides diversity in living things, is mutation, where you change the DNA. And so that's where we're going. In order to understand why a mutation would change a protein shape, we need to think about how you get the information in DNA into the information of protein, and that's where we'll go next classes. All right, blank in blank can cause proteins to be a different shape and not function properly. What do you think? Mutations in DNA. That's right. I hope you have a great weekend. We'll see you back together on Monday. Take care out there and see you.